Yes. So what we have done in the previous lecture is we have started with the introduction of partial differentiation, and I've told you how do we do the differentiation. When we have more than one independent variable, we do the partial differentiation of a given function. If z is a function of x comma y, then partial derivative of z with respect to x denoted by delta z by delta x denoted by delta z by delta x is obtained by differentiating the function z with respect to x, taking y as constant. Okay, so let us take some examples on this now. This type of questions will be there for your MCQ. Take out the first one. If u is equal to x raised to y, if u is equal to x raised to y, then find the derivative of u with respect to x and derivative of u with respect to y. So your function u is depending on how many variables? It is depending on two variables, and that's why we are going to use partial derivative. Okay. So what is the meaning of partial derivative? When I'm differentiating with respect to x, I'll be taking y as constant. Yeah.
Y constant.
Correct. So u is equal to x raised to y. So let us do the first one. I do one. You do the second one. By u by x, derivative of u with respect to x, partial derivative will be x is a variable and y is constant now. So this will become of the type x raised to constant. So what's the derivative of x raised to constant? Constant x raised to
y
constant.
into x raised to
Y into x raised to y minus 1. Y into x raised to y minus 1. That's your partial derivative. Is it okay? Simple. Similarly, try to find what is the partial derivative of u with respect to y. Now, y will be a variable.
X raised to y log.
x raised to y log
Y
x.
log x. Why this is so? Because it is of the type a raised to x. So derivative of a raised to x is a raised to x log of a. So x is your constant, y is your variable. Don't get mixed up with this x and this x. This is a constant, x is a variable. Then x is a constant, y is the variable. So it is x raised to y log of x is your answer. Is this okay? So these are the first order derivatives. So take one more example as you saw. This was the first example. Find the first order derivatives of z is equal to tan inverse of x by y. Find the first order derivatives of tan inverse of x by y. Tan inverse of x by y. So when you are differentiating z with respect to x, first order derivative means derivative of z with respect to x, y will be constant. Derivative of z with respect to y, x will be constant. So try to do that. So derivative of z with respect to x, that time y will be constant. So what it will be? Tan inverse derivative you will take for. This is function of function. Tan inverse of x by y. So outside tan inverse is there and inside function is again depending on x and y. So it is a chain rule. We are going to use chain rule. So what's the derivative of tan inverse?
1 upon 1 plus x square.
1 upon 1
1 upon 1
plus
plus x square. So what is x now? X by
X
y.
x square
X
by y
by
square.
y. Yeah. So it is x square by y square into derivative of x by y with respect to x. Is this okay? This is called a chain rule. So derivative of z with respect to x will be tan inverse derivative first and then multiply with derivative of x with respect to derivative of x with respect to y. So what will be that? Delta z by delta x. I have to write a tan inverse of function and all that. So I am writing a chain rule. First take the derivative of tan inverse, which is 1 upon 1 plus theta square into derivative of theta with respect to x. So this will become, I simplify this. It will become y square upon x square plus y square. Is this okay? Take the LCM. It is y square plus x square. Y square will go on top and multiply by derivative of this with respect to x. So 1 by y is constant. 1 by y is constant and derivative of x with respect to x is 1. So when you simplify this, this is y upon x square plus y square. 1y will get x. Is this okay? Everyone? Deva z by deva x will be
Yes, ma'am.
y upon
Yes,
x
ma'am.
square plus y square. You find what is deva z by deva y?
Minus x upon y square plus x square.
Minus
Hmm.
x upon
Y
x
square
square
plus
plus y square. Yeah, y square plus x square or x square plus y square. Yes, that's correct. Everybody is getting it, or should I show you how to get it?
Yes.
First of all, 1 upon 1 plus x by y the whole square, that will be obviously there. Deva z by deva y will be 1 over 1 plus x by y the whole square will be there into the derivative of x by y with respect to y. So x will be constant, it will remain as it is. 1 by y derivative will be minus 1
Minus
by
1
Minus
y
1
square.
upon y square.
Yes. So it is y square upon x square plus y square into minus x into y square upon x square plus y square into minus x upon y square. So y square cancel, and therefore derivative of z with respect to y is minus x upon x square plus y square. Absolutely right. Is this okay, everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay.
ma'am.
So these are your these are partial derivatives of first order. Can you tell why they are called as first order partial derivatives? What do you mean by order? Order
How
of the
many times we
derivatives?
differentiate? The time.
Absolutely right. Yeah.
Variables are for 1.
Yes. Number of times. How many number of times it has been differentiated? So the function here is differentiated only once, and that's why it is called as first order derivative. Now the question that I want to ask you is, if z is a function of xy, everybody has written this?
Yes, ma'am.
Yes, ma'am.
Examples? Yeah. So tell me now, if your z is a function of x and y, how many second order derivatives are possible? Second order derivative means what? You should be differentiating it two times. You should be differentiating it two times. Yes. Tell me how many?
4.
Yes, four is the correct answer. First approach, even if you say 2, it's good. But which 2 you are going to talk? Tell me. First derivative z with respect to x. This is first order derivative. Correct?
Yes, ma'am.
Now, yeah. Now what you are going to do? Second order means one more time you want to differentiate. So how can you differentiate this term? How with respect to which variable you can differentiate? You can either differentiate with respect to x
Y.
or you can differentiate with respect to y. Correct? Na?
Yes, ma'am.
Whatever is your answer, that will be some function in xy. So you can differentiate it with respect to y, and you can differentiate with respect to x. So these are called as the one more notation is also there. This is called as zxx or deva square z by deva x square. Is this clear? Both
Yes,
are
ma'am.
same. Zxx means differentiate z with respect to x twice. What is this? This is z by x, which is the order that I follow. Outside one is differentiate it first, and then the inside one later on. So, what is the meaning of z by x? First differentiate z with respect to x, and whatever is the answer, differentiate with respect to y. Is this clear? Zxy means deva square z by deva y deva x. Is this clear? Yes.
Yes,
Yes,
ma'am.
ma'am.
On the
Yes, ma'am.
same, yeah, on the same
Yes,
line,
ma'am.
what are the other two partial derivatives? You can differentiate z with respect to y first and then differentiate it with respect to x. So you will get deva square z by deva x deva y, which is denoted as zxy. Zxy. Okay. One more question for this can be asked like, what is zxy? So they give you deva square z by deva x deva y, they give you deva square z by deva y deva x, x and y. So the one who generally the students get confused, they write it as yx. No, this sequence which is there, it is reversed. X first and then y. So x z, when I am writing deva square z by deva y deva x, that means y will be outside and x will be inside. Is this okay?
Yes, ma'am.
Okay.
Yes, ma'am.
And the last one is deva square z by deva y square, and that is z y. So there are four partial derivatives of second order. There are four partial derivatives of second order. Now, these four which are there, sometimes they become the mixed product which is there, mixed partial derivative which is there, they become equal. Is that okay? What which one? Zxy and zyx, they become equal. And when is that possible? If your given function is continuous as well as the partial derivatives are continuous, then only the mixed partial derivatives are equal. What is the requirement? What is the condition for the mixed partial derivative to be equal? Zxy should be equal to zyx. When does this happen? If your function is continuous and the partial derivatives what they have after you differentiate it, those also should be continuous. So which are the continuous functions that we know till now, whatever we have studied about continuous function, all those who can be drawn without lifting the hand, those are continuous functions. Okay, but what are the general ones which we have already always we have done? Trigonometric functions are continuous because they can be written as series expansion. Logarithm, what is that? Logarithmic curve, we know that it is continuous. Then any polynomial is continuous. Exponential is continuous. And the examples that you are coming across will be all these continuous functions only. Tan inverse x, the curve, you know that is also continuous. Getting it? So that's why maximum questions which you are having, or rather all the questions that you are going to have, will be having the mixed product to be equal. So if they ask you which are the possible second order different partial derivatives existing, different, then you have to check whether the mixed derivatives are equal, and you say they are only three. Because lemma xy will be same, zxy will be same as zyx. If they say distinct or different, but if they say how many possible second order partial derivatives are there, then the general answer is 4. Is it okay?
Yes, ma'am.
Okay. So now we'll go one step ahead and we'll find out the mixed derivatives and partial derivatives of order 2 for a given function. Take down the first same function. If u is equal to x raised to y, if u is equal to x raised to y, then if u is equal to x raised to y, then find all second order derivatives of the given function. All second order derivatives of the given function. One by one step we'll go ahead. Okay. So what's the question? U is equal to x raised to y. You have to find the all four derivatives of second order, or four derivatives of second order. So what's the first one? We have already found what is the first derivative. U is equal to x raised to y. So we have already found what is del by u by del by x, and that is nothing but y x raised to y minus 1. Okay, and del by u by del by y is equal to x raised to y log of x. So now I write down what is uxx. Derivative of u with respect to x twice. Okay, so what will be the answer? Differentiate with respect to x, your answer of u with respect to x. That is, differentiate with respect to x, y x raised to y minus 1. Here who will be constant? Y will be constant. X is your variable. So it will become y into y minus 1, x raised to y minus 2. Is this correct? Everyone? Yeah, everyone. Y into y minus 1, x raised to y minus 2. That is your uxx. On the same lines, you find uyy, uxy, and uyx. And tell me the answer. Everyone, you do it on your own. These are simple examples, and such type of examples will be there. So, uyy is derivative of this term with respect to y. So log x is constant, it will remain as it is. X raised to y will again become x raised to y into log x, and therefore your answer is x raised to y log of x the whole square. 2 times of x. Correct? Yes? Then uxy. So what's the order? The first derivative is to be taken with respect to y and then with respect to x. So partial derivative with respect to x of u with respect to y. So what is u with respect to y? X raised to y log x. X raised to y log x. So what will be your answer now? When you differentiate with respect to x, y is constant. Y is constant. So here you have two functions of x. So what you are going to use? You are going to use product rule. All the rules of derivatives are same. So what will be that? X raised to y derivative is y, x raised to y minus 1 log x as it is. Please be careful and listen properly, okay? X raised to y derivative with respect to x is y is constant, so y x raised to y minus 1 log x as it is. I am using product rule plus x raised to y as it is into derivative of log x, that is 1 by x. Therefore, uxy is nothing but x raised to y, x raised to y minus 1. Okay, this is also x raised to y minus 1. Can I write it like this? Just see whether you understand this step. The second term is x raised to y minus 1 because 1x is there in the denominator, it will go on top as minus 1. So it is x raised to y minus 1. This is also x raised to y minus 1 that I can take common. What remains inside the bracket is y log x plus 1. Clear? Is that clear to everyone?
Yes.
Yeah. And now similarly, you find u by x and see whether they are same. What is u by x? Derivative with respect to y of u with respect to x. Do it and see what is the answer. U with respect to x is nothing but y x raised to y minus 1. And therefore, the answer of this will be, I'll write it on top. From here I am going here. So y is your variable, x is your constant. Derivative of y with respect to y is 1, x raised to y minus 1 plus y as it is. Derivative of x raised to y minus 1 is x raised to y minus
1 log x.
2 log x. And that becomes x raised to y minus 1, you can take common, 1 plus y log x. And therefore, both the mixed derivatives are equal. Uxy and uyx are same. So that will be one question that can be asked, what is the mixed derivative? So first type of example that you will see is uxy is equal to uyx when a function is continuous. So x to the power y is a function which is continuous, and that's why we are getting that the mixed product. The other way around need not be true, but since if it is continuous and the partial derivatives which are existing are also continuous, they are looking at polynomials, considering one as variable, other as constant. That's why the mixed partial derivatives are equal. Okay?
Yes, ma'am.
Yeah. So let me now tell you what are the different type of examples or what are the sections in this unit that we are going to go through. So is the basic clear to everyone how we are going to differentiate partially?
Yes, ma'am.
Yes, ma'am.
Okay. Now I think one of the students from the advanced learner, whoever wants to take up this topic and try to find out the geometrical interpretation of partial derivative. The way, what is the meaning of ordinary derivative? Slope of the tangent to the curve. So one of you all, yesterday we have shared the list of advanced learner. From all those advanced learner, there are 8 students from C division and 8 students from D division. You can take the topic, one of the topic as geometrical interpretation of partial derivative. Okay, that you have to explain to the remaining students or entire division. We'll see you can do schedule that lecture. But anybody from those 60 students can take this topic, geometrical interpretation of partial derivatives. It will be definitely related to slope only, but what which slope? Whether it is a line or a plane or what it is that you go through, you will get it in your textbook, reference textbook also. B.V. Ramana, you will get it, or you can go for Fredzik, you will get it in that. Okay? So one of you can take that topic. Now let us go to the
No.
yeah.
Ma'am, you have not provided the list of
Advanced learner. Okay, I'll share it. I'll share it with you today. Okay. Before today I did not. I forgot my share it home. So in the evening I will send you the list. Right. So let me now tell you what are the topics that we are going to see in this particular unit. First of all, we are going to do the part which will be giving you all types of partial derivative equations. If they may be complicated, they may be simple. All partial derivative techniques we are going to learn in this unit. And then the application we are going to see in next unit. Unit number 3 is totally how to get the partial derivatives of functions which are simple or which are complicated, which are function of function, composite functions, Then the functions which are homogeneous. Then what do we mean by variable treated as constant? All this kind general way of looking at a question or looking at a function whose partial derivatives have to be found will be done in unit number 3. And its application will be seen in unit number 4. So there are various applications of partial derivatives. For example, like we can find error in a function, we can find dependency of two functions, we can find maximum minimum of functions which are having more than one independent variable. Those all are applications of partial derivative which we will do in unit number 4. But right now in unit number 3, we are going to see how do we get the derivatives of functions which are either plain functions or they are composite functions, functions of functions and so on. Okay. So let me write down the topics that we are going to go through. The first one is direct evaluation of partial derivative. You can write down the topics if you want. Direct evaluation of partial derivative. For example, the ones which we have started with, right? Direct evaluation of partial derivative. Now the function that we had seen were explicit function. U was given in terms of xy. So U was given in terms of xy. So directly I can differentiate U with respect to x or U with respect to y. Sometimes the function are implicit. What do you mean by? Can anybody tell what's the meaning of implicit function? Guess it. You did not tell me the correct answer.
X and Y will be dependent on each other. Like it will be a single function with two variables.
It will be a single function such that
It will have X and Y in the same function.
x and y in the same function. X and y can
But
be
X and Y can't be
Where X and
separated.
Y cannot be separated.
correct.
No,
Very good.
it is some kind of explanation.
Yes. So for example, like
Circle
if we
equation.
have
Circle
circle equation, we can write it as explicit. Circle equation is what? X square plus y square is equal to r square. With center 0, 0 and origin as you can say, center is what? Sorry, 0,
Origin.
0, and yeah, origin and radius is r. Okay, but this can be written as y square is equal to r square minus x square. So y is a function of x. So this is one variable function, isn't it? I want partial derivatives means what? It should have more than one independent variable. So will this be a example for implicit function?
No, ma'am.
Yeah.
In the
Ma'am, x and f of x, like that.
in the exponential form.
Give one example. X and f of x, if you say f of x comma y, you're saying.
No, ma'am.
Try to identify examples and tell me. One of the examples that I can think about is x cube, say, plus y cube minus 3axy plus 3ax square y is equal to 0. Is it possible to combine or collect the terms of x and y in such a way that x will be totally on one side and y will be on the other side? This is an example. This is an example of two variables only, but still it will be implicit function. How to do the derivative and that I will do later on. But if I want to talk about implicit, this was possible because y was written on one side and x was written on the other side. What about this example? Can it be converted to x as a function of y or y as a function of x? Can I get anything common? From this two, if I take common x square, I will get 1 plus 3ay. And from this, I have to take y square, y common, but still one more y will remain there. So I cannot separate them out as y as a function of x or x as a function of y. That time it is called as implicit function. Is it okay?
Yes.
Everyone? Yeah. So that is the meaning of implicit function. Now, for example, z cube minus 3xz plus zy minus 1 is equal to 0. Let's see whether I can separate out. I want to write z as a function of xy. I'm giving you now a function in two variables. Can this be done? Or if I write here z square. Can this be done? If it was z, still I could have taken that z common and z cube minus 1 on other side divided by z, I would have got it. Isn't it? Can I separate out this z and xy term?
No, ma'am.
No.
If it was Z, if it was only Z here, in place of Z square it was Z, then I could have taken Z common. Okay, Z cube minus 1 or minus 1 also I could have written that side. If I take Z common, then I would have divided by then and got the answer something like this. Z cube minus 1 is equal to, if it was only Z, then Z I would have taken common and I would have got 3x minus y.
Minus 1.
Okay, so Z cube minus 1 upon Z would have become like this. Is it okay? Fine. Then differentiating Z alone is possible and xy alone is possible. But here, right now, we cannot do anything of this type and directly it will be implicit function. So if I want to differentiate such type of equation, what I will do? If I want to differentiate this type of function, what I am going to do? Suppose I want to find what is the derivative of Z with respect to x. What I will do in this case? And that is called as differentiation of an implicit function with respect to x or y. If it is asked delta z by delta x, or it is asked to find the value of delta z by delta y. So what you'll understand first, that z is depending on x and y. Are you getting it?
Yes, ma'am.
Okay, and then when you are differentiating this with respect to x, first of all you have to take the derivative of z cube also, because inside z cube there will be x and y term if z is depending on x y. समझते हैं आप सगळ्यांना या इक्वेशन मध्ये I cannot separate out, so I have to take 3z square into delta z by delta x minus, if I am differentiating with respect to x, here there are two variables which are depending on x. X is itself depending on x as well as z is depending on x. समझते हैं? Is this clear?
Yes, ma'am.
Yes.
So minus 3 derivative of x with respect to x will give us z as it is plus 3x as it is into delta z by delta x.
Z by delta x.
Is this okay? And then it will be plus 2z delta z by delta x. Y is constant, so it will remain as it is and is equal to 0. Such type of thing. Is this clear? And from collecting the terms of delta z by delta x, I get the value of delta z. That is called as partial derivative of implicit function. We'll do examples on this also. Is this clear?
Yes, ma'am.
This all comes under direct evaluation of partial derivatives. They may be explicit function or they may be implicit functions. Clear? So the type 1 that we are going to see is partial derivatives of direct partial derivatives of function, which will be either explicit or implicit. Then the second topic that we are going to see is, already we have done one example on that, verification of mixed product. Verification of mixed product. So what is that? What is the meaning of verification of mixed product? Verify whether zxy is equal to zyx. And this is possible if z is continuous function and partial derivatives of z are also continuous. Please write down this case, okay? This will definitely ask for 1 mark. Now, one small thing that I wanted to tell you is the university has said that there will be 60 questions till now for all of the branches, all the subjects. They have said 60 questions will be there in your final exam, out of which correct 50 will be considered. This is what the circular is being sent by university. So for maths also, if it is so, then it will have only 1 mark questions. So basically, they'll ask the 2 marks question also for 1 mark. At least 50% of the 60 to 70% questions will be easy or 1 line, 2 line answers in solutions. But they can ask 2 marks question also for 1 mark. So you will have to improve on your speed. Otherwise, completing the paper will be difficult because they give you 1 hour 60 questions, out of which 50 will be considered. Are you getting it?
Yes, ma'am.
Even if for maths, for maths they reduce the number of questions, which is difficult right now because maths people are also saying that university has done a fixed rule for all the software only designs and that 60 questions should be there and 50 out of that best 50 will be taken. Okay, so that's why even if for maths it is 60, it will be really difficult for solving them in 1 hour. Rather they are 50 questions, but still it will be difficult. So you will have to improve on your speed. So please practice MCQs, and that's true for all the subjects: electrical, mechanics, maths, physics, all. Okay, physics, chemistry, electronics, electrical. So please see to it that you practice MCQ examples as many as possible. Okay. So such type of question can be asked. When is the mixed product equal? The answer will be Z should be continuous and possess continuous partial derivatives. Okay.
Yes, ma'am.
Then the third point which is there in partial derivative is variable treated as constant. Variable treated as constant. Can anybody guess what will be this question? What will be this fact? Till now, when you are finding the partial derivatives, we are taking something to be constant only, isn't it?
Yes, ma'am.
Then what will be special about this? Variable treated as constant. Partial derivatives are as variable treated as constant. Just think and tell me. Should I ask some particular student? That will be better. Yes, roll number, when we had stopped in the morning, I think so 4. Roll number 6, division D. Shivam?
Yes, ma'am. Can you repeat?
Variable treated as constant. Partial derivatives with a special condition that variable treated as constant. What do you think will be the difference between normal ordinary partial derivatives and this particular case? Can you guess? I don't expect a very correct answer, but can you guess what it will be? Just think literal meaning. Always you try to go for literal meaning first. Whenever a point is there, go for the literal meaning of that words. Whatever are being written. Variable treated as constant.
Ma'am, if in a function we are given that two functions are given, or for example, any constant value, or what I'm trying to say is,
Yeah.
whenever we differentiate the functions, so in case if we have many functions for differentiating, so we will suppose one variable or more than one variable as constant.
Is this Shivam only, na?
No, no, ma'am. I think I am not that.
Okay. Who was
Someone else
that?
has told.
Yes, yes. Who is that? Can I get the name? You are absolutely right. See.
ENTC roll number 16, Rohit.
Rohit, okay. Gabi Ward, na?
Yes.
Good, good. See, it's the literal meaning only. Variable treated as constant means they are going to tell you which variable to be treated as constant. For that, obviously, Z should be depending on more than 2, 3 variables, 4 variables, or the equation won't be directly given in the variables. You have to convert first Z in terms of those variables, and then take the given specified variable to be constant. For example, suppose you have the function as x is equal to r cos theta, y is equal to r sin theta. X is equal to r cos theta, y is equal to r sin theta. And you are asked, find the partial derivative of r with respect to x taking y constant. Let me write down. Simple. This is the simple equation in 2 variables only. X is equal to r cos theta and y is equal to r sin theta. Okay. Right? Then they are asking you to find partial derivative of r with respect to x taking y constant. This is the question. Find the value of r by delta x taking y constant. Now they will tell me, elaborate and tell me what you will be doing here.
Ma'am, we can take r square is equal to x square plus y square.
Very good. So r square is equal to x square plus y square. You will first convert it, because which are the variable that you want? R should be depending only on x and y. Here r is depending on x and theta. Here r is depending on y and theta. Which equation you are going to use to differentiate? You have to use x as well as y. So first you have to eliminate theta. You have to eliminate theta. Get the equation of relation between x, y and r, and then differentiate with respect to x. So what will be the derivative? 2r deva r by deva x. First I have differentiated r square, which is 2r. Then deva r by deva x is equal to 2x, and therefore deva r by deva x will be x by r. Is this okay? Clear to everyone? समझ गए ना? What is the meaning of variable treated as constant? They may not give you directly the variables in which it is expected to be. they give you some equations from which you can convert r as a function of xy and then differentiate it with respect to x or y, which is expected in the answer. This is clear. This is called as the technique of finding the partial derivatives by variable treated as constant. Clear? Yes or no?
Ma'am,
Yeah.
Yes.
every time it would be possible to remember in this time it was okay that x is equal to r cos theta and y is equal to r sin theta. Then we can derive r square is equal to x plus, plus y square. But every
Yeah.
time it won't be possible to remember
Yeah.
the
No,
relationship.
you don't have to remember. You don't have to remember. They give you the function. They give you x is this, y is this. And they'll ask you find the partial derivative of r with respect to x, making y constant. So that time you have to convert r as a function of xy with the help of this equation. Equations will be given. Otherwise, we are not given equations also, and we are not given any relation how to differentiate, isn't it? So basic equations will be given to you, but those equations won't be directly in the form of expected derivative. जे डेरिव्हेटिव्हज आपल्याला द्यायचे त्या फॉर्म मध्ये ते नसणार. या दिलेल्या इक्वेशनचा वापर करून आपल्याला कन्वर्ट करावं लागेल आणि मग डिफरन्शिएट करावं लागेल ह्या व्हेरिएबल बरोबर दुसरा व्हेरिएबल कॉन्स्टंट घेऊन. Clear?
Okay. Yes.
Everyone? Okay. This is one example, and this was known to you. These are the polar coordinates of x and y, isn't it? So that means spherical polar coordinates are also there. So are you going to remember them? When you will be going for multiple integration, that is in M2 when you are going to find double and triple integration, that time double and triple integration, you will have to write down those equations of x, y and z in terms of r, theta and phi. But for that first we do see the geometry and then we'll go ahead. So that's not the thing to be remembered right now. The equation definitely will be given to you and then you have to use them in the expected form. Clear? So the basic thing will be you will have to convert if not possible. Suppose in the same question you are asked differentiate x with respect to theta taking r constant. Then it is straightforward. Del by x by del by theta taking r constant.
Yes, ma'am.
Then it is directly given in the expected form. So what will be the derivative of x with respect to theta? R is constant, it will remain like it is. Derivative of cos theta is minus sin theta. So your answer will be minus r sin theta, which is nothing but -5. This is okay?
Yes.
Yes, ma'am.
So yeah. So if this is asked, then you have to convert. If this is asked, you can do directly. So let us go. That is the second topic that we have to see. Right? Next, which is there is after that we are going to do Euler's, or sometimes students call it Euler. Euler's theorem for finding partial derivatives. Now this is a very special theorem which gives you the value of the partial derivatives second order xx, xy, yx and y square within a statement. You don't have to actually do the partial derivatives, only you have to check whether the function is homogeneous or not, and then directly there is a formula which will give you first order partial derivative, second order partial derivative and some equations. So that comes under Euler's theorem for partial derivative. Okay, for which we should know what we mean by homogeneous function. So again, anybody can guess what is homogeneous meaning? What is the meaning of a function is homogeneous?
Ma'am,
All
the
the powers
total
are
order
on
of
the
All the
same.
powers are
Very good, very good. Those who have done this part, then they will be knowing it. If you have not done homogeneous means it should be equal. What is the thing which can be equal about any polynomial function or any function which is having xy terms?
The order.
Powers.
Order.
Yes, powers.
Order.
Yeah, order of that.
Three order.
Yeah, so all the terms, order means what? All the terms which are appearing in that function should have same powers. For example, if your u or your z of x comma y, this is a function which is x cube plus y cube minus 3x square y plus 3xy square. How many terms are there? 1, 2, 3, 4. Yes or no? There are 4 terms.
Yes.
What is the power of each of the term? Power of, yes, 3. Y cube is also 3. 2 plus 1. Those who are a bit weak, they will not understand directly. It is 2 plus 1. Power of this term is 3. Power of this term is also 3. So each term which is appearing in the function should have same powers or same degree, then it is said to be homogeneous. Okay? If it is a polynomial by polynomial or function by function, then the numerator should have all the terms of same degree denominator should have all the terms of same degree, then entirely what will be the degree of the function?
0.
If they are equal, it will be 0 na. In general, if they are not equal, numerator की अलग है, denominator की अलग है, तो what will be the answer?
1.
Why 1?
Numerator upon denominator.
It depends.
It will
Numerator upon
depend on the
denominator.
numerator and denominator.
Denominator.
It will depend, but what it will be in general? Z is a function x comma y, which is
Ma'am, if numerator's degree is greater and the denominator is degree is small, then it would be infinite.
if the degrees are finite, then the ratio will never be infinite. Degree of the ratio will never be infinite. Just see here. This is f of x. Suppose the degree of this is p and the degree of denominator is q. Is it okay? Then what's the degree of entire function? And
P
both
minus
of them are
P minus
P minus
P minus
ultimate. So it is p minus q. How will be infinity? Getting it?
Yes.
Yes, ma'am.
Yes.
Yes.
Yes, ma'am.
बेसिक क्राइटेरिया ऑफ डिग्रीज ऑफ पावर्स ये कैसे होता है वो एग्जांपल से हम लोग देखेंगे एंड व्हाटएवर वी हैव सेड जस्ट इन वर्ड्स नाउ डिग्री ऑफ ईच ऑफ द टर्म इज सेम दैट वी विल आल्सो सी हाउ वी आर गोइंग टू राइट इट मैथमेटिकली how why I say that degree of each of the term is same, then what I can take common and how I am rewriting the given function. It will be written in the form x raised to p function of y by x or y raised to q function of x by y. So what is the meaning of that? That all we will see when we will be tackling Euler's theorem to find the partial derivative.
Ma'am,
Okay?
your fx should be equal to gx, no?
No. I'll tell you what is that. It's, the degrees did not be same. The functions did not be same. If you are saying functions are same, that means the powers will be same, and then the degree will be always 0.
Ma'am, here in denominator there should be a condition like g of x is not equal to 0.
Definitely, it's not a zero function. Otherwise, the division only is not possible. It's not well defined. It's a polynomial in xy. Isn't it? It will be a polynomial in two variables xy because it is gxy. So it cannot be a zero polynomial.
What if q is greater than p?
If
What
p
if q is greater than p?
your degree can be negative. Now, what is the meaning of degree is negative? Your function will be of the type 1 upon something.
Yes.
Negative degree is allowed. Positive degree is allowed. 0 degree is also allowed. When both of them are having same degrees, it will be 0. Special case that will be.
Okay.
Isn't it? समझते हैं ना सगळ्यांना? Degree is the same as p is equal to q is 0. If p is greater than q, positive. If p is less than q, negative. No problem if you are having negative degree also because the function will become of the type 1 upon x square. What's the degree of 1 upon x square?
-1.
-2. -2 upon x square.
Sorry, -2. Yes.
Is it okay? So no problem with that. How to go ahead with those degrees that we'll see later. Okay? So that's the point. Fourth point, that is Euler's theorem. And the most important point is total derivative and differential. Total differential and total. Okay, I have skipped on one point that will also do. Total differential and total derivative. This is the term which we are going to use to find the change in a variable with respect to the other variables when the percentage change is given in the remaining ones. For example, z is a function of xy, and if there is error in x and y which is given to you, what will be the error in z? That will be found with the help of total derivative or total differential. So that we will see in this part. That is the fifth part. And one more part which is there is composite function, where we are going to use chain rule to find the partial derivative. Okay, so in your engineering, most probably you will come across composite function. Euler theorem is actually this third, fourth, fifth, and sixth. They are more important. Third, fourth, fifth, and sixth. Okay, Euler's theorem gives you the answer without solving, so it is important. Total derivative actually has application. The functions which you come across in engineering are composite function. If function dependent directly, such type of questions or such type of equations will be very rarely you will be coming across. They will be functions of functions, and then how do we get the partial derivatives of that? We will check. Variable treated on as constant is important because that will give you the insight. How do we convert one type of function into different variables? So if it is easier to study the equations by converting them in the other variables, then variable treated as constant will be easier or important from engineering point of view. Okay, so these are the 6 topics that we are going to see in unit number 3. So the first one is direct evaluation of partial derivatives. 2 examples we have already done. U is equal to x raised to y and z is equal to tan inverse of x by y. Now we'll go to some questions wherein it will be either implicit function or some complicated question. So take down the next question. Take down. If u is equal to log of x cube plus y cube. This is the kind of question that you can write down here. If u is equal to log of x cube plus y cube minus x cube plus y cube minus x square y minus xy square x square y minus xy square, then prove that delta by delta x plus delta by delta y, delta by delta x plus delta by delta y, the whole square of u is equal to minus 4 upon x plus y the whole square. Minus 4 upon x plus y the whole square. Now the examples that we saw earlier, they were quite simple and we got the answer within one step because it was only finding the partial derivative. Now you are given a function which is in terms of log and you have to find a complicated partial derivative equation. Delta by delta x plus delta by delta y the whole square into u is equal to minus 4 upon x plus y the whole square. So first of all, looking at the question, you should understand what you have to find. Can anybody tell me what we have to find? Left hand side you have to start with and you have to prove the right hand side. What is the meaning of left hand side? Delta by delta x plus delta by delta y the whole square of u. Which one? Quickly.
Ma'am, we have to differentiate first with respect to x, then with respect to y,
And
Add
then
it.
and
then
add it,
square
then square it.
Square it.
Adding us
and then
Again
See,
differentiate it.
into and
multiply by u.
yes.
multiply by u. Yes.
Squaring, what you are saying is squaring. What is delta by delta x? Is it a variable or is it an operator? What do
Ma'am,
you
it's
mean
the
by
operator. Can we expand the bracket?
yes? You can expand the bracket and then apply that operator on u. That you can do. That's one way. Okay. Second way is what you are saying, square it. Again, it will be treated as operator only. This is delta by delta x plus delta by delta y of delta by delta x plus delta by delta y of u. Correct? That square I have split it. The operator is repeated. So it was written
Yes.
square. Okay. Now operator is operated on the operand. याच्यावरती apply करतोय ना आपण u वरती. So I can write it here. Is this okay?
Yes, ma'am.
So you get this will become delta by delta x plus delta by delta y of v. What is v? Delta u by delta x plus delta u by delta y is your v. Clear? So that will be some function, and on that function again I am going to operate this particular operator delta by delta x plus delta by delta y. So is the meaning of that equation clear to everyone first? Square म्हणजे एकच ऑपरेटर दोन वेळा अप्लाय करतोय. Delta by delta x plus delta by delta y, that is operated twice. So first let me operate it once, get the answer of it, and then whatever is your answer, again operate same operator on b. Okay? Yes, is this clear?
Yes, ma'am.
Okay. Now you try to find b. That is easy. Still you have to think whether you can directly go for the derivative. वो ते पण जरा विचार करा. Directly दिलेल्या function, the function which is given to you, u is equal to log of x cube plus y cube minus x square y minus x y square. Will you directly go for the derivative of this, or can you try to simplify the equation?
We can simplify
E
it.
power u
Try to
घेऊन
simplify.
करू.
You can think about simplification.
We can
Yeah. What makes you think that you should simplify it?
Log चा
Because
derivative 1 upon that function.
Log can
The powers are same.
the The powers are same. That's one of the thing. Very good. And
In log function, when there is multiplication of two function, we can separate log x, log a plus.
very good, very good. Why did you think of going like that only? When there are obviously when there are some when there is a sum of three or more terms, and if there is something common, we can write it as product, and that product can be of the form AB. Log AB will be log A plus log B, and then we can separate it out and differentiate, which will become easier. One more hint is there in the question which tells you that simplify you. Don't go direct for direct derivative. One more hint is there in the question.
We have to differentiate
Formula.
with respect to x and with respect to y. When we are doing that, one term will be zero and only one term will be differentiate, ma'am.
So you're saying that you will get when you are trying to convert that internal function as to be in terms of product, you will get only function in x and only function in y. असं विचार येऊ शकतो. If you get that way, then obviously it will become more simple. But I don't think so. It will become explicitly in terms of x and y. It will have x, y terms both together. The hint, anybody else can think? What is the hint? That you have to simplify the
There is
function.
a formula.
E raised to u.
You can think about e raised to u also, not a problem. But then your differentiation of u will become e raised to u, derivative first and then and again back substitute. That again will become a bit complicated. I'm asking you the hint why you should simplify u. And why I'm asking you this, because you should think and you should not feel it is a monotonous way of doing it. Try to put stress at the gap.
And because denominator.
Ma'am,
Yeah.
A plus B whole
we
cube.
can write du by dv dy is equal to v plus.
That you all are telling me the techniques how to solve this example. I don't want the technique. I'm asking you when you're trying to solve this b, you're trying to find this b, you have to differentiate u with respect to x. So are you going to directly differentiate log of this? So it will become 1 upon x cube plus y cube minus x square y minus x y square into derivative of the entire function with respect to x. ये करने के बाद what will happen? You will have a big equation which you have to simplify and try to get it. Okay, into some small thing and then do the solution. But it will become tedious. So after doing it, understanding that this is something which is going to make me helpless, you should think before starting, is there any other method? One way that you told me, that since there are terms, 4 terms, you can club them together and get the answer. That is obviously good way of thinking. Since there are 4 terms and they can be clubbed, that's why I'm going for simplification. The other reason I'm asking you, which is clearly given in the question, the hint of the answers are generally given in the question itself.
You have given that
Ma'am, we can use the expansion
X plus y whole square.
Yeah, yes. That's the most important is that your final answer is only a small function minus 4 upon x plus y the whole square. Isn't it? So that means you should get something like x plus y in the denominator when you're finding b. And when you're going to differentiate it one more time, it will become minus 1 upon x plus y the whole square, minus 1 upon x plus y the whole square, which will become minus 2 upon. So obviously if it is 4, there should be 2 upon x plus y. 2 upon x plus y. And then you will have, take the one more derivative, it will become minus 2 upon x plus y the whole square, minus 2 upon x plus y the whole square, which will give you minus 4 upon x plus y the whole square. Are you getting it? How you have to think? If you want to think 4 steps ahead, then look at the question carefully and the answer is turning out to be very small. So when can I get this answer? If one of the previous derivative, we have written this, one of this previous derivative, that means v. V should be such that it should be minus 2 upon or plus 2 upon x plus y. Is it okay? So when will I get x plus y? If this bracket gets simplifies in x plus y and x some other term. Isn't it? That's why you have to go for clubbing the things and comparing it with log of AB, which will be written as log A plus log. Is it okay?
Yes, ma'am.
So let us do it now. So all this was only to make you understand how you should go about any question. So let me write down now. This is u. So u can be simplified as log of, take from which terms I want to take common? First and third term.
Yes, ma'am.
Take x square common. समझते हैं सभी पहिल्या आणि तिसऱ्या टर्म मधून मी x स्क्वेअर कॉमन लेते हैं टेकिंग x स्क्वेअर कॉमन दोनों फर्स्ट और थर्ड टर्म में से मैं x स्क्वेअर कॉमन लूंगी तो मुझे क्या मिलेगा x minus y and then I take common from second and fourth term तो y स्क्वायर अगर मैंने कॉमन लिया so what I will get y minus x
y minus
Okay, so since I want x minus y, I'll change this sign.
Y square.
Yes, so this will become x square, x minus y square, x minus y. And therefore, I can write this as log of x square minus y square into x minus y. Okay? Yes or no?
Yes, ma'am.
Yes, ma'am.
So this,
Yes,
so this will become log of x square minus y square is x minus y into x plus y into x minus y. And that will become log of x minus y the whole square into x plus y. So this is log, this is a, and this is b. What's the formula for log AB? Log
Log
AB is log A plus
Log A
Okay, plus log B.
plus log B. Again, I'm writing here the result says log AB is log A plus log B. Further, still you can simplify this. This is log A to the power B. So that is B, that means 2 log of x minus
Log
y
of x.
and plus log of x plus y. Now it is as simple as that. Is this okay? You now go for the differentiation and you get the answer in more easier way rather than going for direct derivatives. So what will be the next step? Should I run this question? So therefore, B which was partial derivative of u with respect to x plus partial derivative of u with respect to y will become, what will be the derivative? I think so it's in time up.
3. Yes, ma'am.
Okay,
Yes,
just let me finish this. One at least week I will do, and then you try at home the remaining part. Tomorrow if you don't get, I will do it once again. So what will it be? This will become 2 upon
Plus
x minus
by
y
x
3x plus
into
y upon x.
plus x, because derivative of x is with respect to x is 1. Okay? Plus 1 upon x plus 1. ये समझते हैं क्या? ये समझ में आ रहा है ना? log का डेरिवेटिव 1 अपॉन फंक्शन x माइनस y का डेरिवेटिव विद रिस्पेक्ट टू x होगा, x का डेरिवेटिव 1, y इज कांस्टेंट, उसका डेरिवेटिव 0. So what will be your answer? 2 upon x minus y plus 1 upon x plus y. That is delta u by delta x plus delta u by delta y. What will be delta u by delta y?
2 upon
2 upon x minus y into derivative of u with respect to y.
minus
That
1.
is minus 1 and plus 1 upon x plus y. And therefore this and this will get cancelled and you get the answer as 2 upon
upon
x
x plus y.
and this is your b. And then your final answer will be delta b by delta x plus delta b by delta y, which will be minus 2 upon x plus y the whole square plus minus 2 upon x plus y the whole square. And that is your answer, minus 4 upon x plus y the whole square. ये समझ में आया क्या? B A. So what you are doing? Again you are applying delta by delta x plus delta by delta y on B. That means delta b by delta x plus delta b by delta y, which is derivative of this with respect to x and derivative of this with respect to y. 2 is constant. 1 upon function का derivative with respect to x is minus 1 upon function square into derivative with respect to x is 1. इसी function का derivative with respect to y is minus 2 upon x plus y the whole square, because 2 as it is 1 upon function का derivative minus 1 upon function square into derivative with respect to y of this term, which is again 1, and that gives you the final answer. Okay, clear? Everyone?
Yes, ma'am.
Yes, ma'am.
yes.
Okay, okay. So we'll stop here. I'll take your attendance, whatever you have scanned. Morning, roll number 22 is present. D division. Roll number 22, D division. Are you present?
Yes, ma'am. I'm present.
Just a second. Now. Roll number 35. Roll number 22. Just show, switch on your video. D22.
D22. Ma'am, actually, I'm using my laptop. Just a second. I'll connect it with my phone and switch on the video for you.
No, it's okay. It's okay. You're there, na? D22.
Yes, ma'am.
D35. D35. You're there. D35. Morning he was not there. C36. C36. You're there.
No, ma'am.
Arya, she is not there.
She's absent.
Yeah, anybody else knows who are, because I can see there are around 6 students who are absent. Because already your lectures are 5 minutes are gone. You please go join. I will take it from this, whatever attendance I've taken. Since you have not written your roll number, it becomes a bit tedious. Half an hour goes in that. Fine, still you leave the class and give your go for the next lecture. Okay?
Thank you.
I've downloaded.
Okay, ma'am.
Yes, ma'am.
Yeah.
Thank you, ma'am.
Ma'am, I was not present in morning lecture.
Who is this?
C roll number 4.
Mustafa, you were there, na? Throughout you were
Yes,
not
ma'am.
there.
I was there, ma'am, but actually I was in the RTO office, so
You have not gone.
I had gone for my license test. Means
Okay. Okay. Now you are present for the entire lecture, na?
yes, ma'am.
Okay. Fine, Mustafa. No problem.